There you go. Can everyone see the screen here? We have some few more people showing up. All right, so since we have a few people here, let's get started. So first of all, we'll go over yesterday's homework. I'll zoom in a bit so you guys can all see this. So the homework was to implement a number guessing game. So the computer will generate a random value in the range of 1 to 100, and then we'll have the user guess until the guess matches the random number. So if the guess is incorrect, the computer will hint whether to guess a larger value or a smaller value. So the examples were, for example, if we're trying to guess 45 and the input is 50, it'll be incorrect, guess lower. If the input is 30, incorrect, guess higher. And if it's 45, and that's correct. So we have some sample code here. First of all, let's import the library. And sample code we have here, let's go over this real quick. We have answer equals random.randint 1 to 100. So this will give us a random integer from 1 to 100. And then guess here is int. We'll typecast the input. So first of all, we're looking for an input from the user. The input prompt is guess a number between 1 and 100. And once we get that input, we change it to a type integer with typecasting int. And then here we have the main loop. So we have while, and then we'll have condition here. That'll keep prompting the user until guess equals answer. And then if the guess is bigger than the answer, we can tell it to go smaller, elif, and then after that, if the user gets the correct answer, we can give that. All right, so just a quick recap of the homework. Did anyone figure out this problem? Cool, Ian's got it. Good job. Jaden's also got it. Anyone else? No? Okay, so since we have a few people that haven't figured it out, no worries. Let's just go over a quick recap of how we're going to code this. So first of all, we already have guess, right? So before we figure out the while loop stuff here, let's look inside this first if statement. All right. So here it says if the guess is bigger than the answer, we'll tell the user to guess smaller. So what's that going to be? If guess, oh, not capital. If guess is greater than our answer, then we can do print incorrect, yes, lower, right? And then we'll loop through again. Does that make sense? And then the same thing here. If guess is smaller than our answer, print incorrect, yes, higher. Right? So can anyone think of any issues that would come up if you just write the code like this? So think about the while loop is looping through. We're always getting the input. Oh, wait, I guess I should put the prompt inside here. Sorry. Tab that over. Any issues with this kind of logic here? Yeah, Ian says it will keep running forever. So that's a good point. Right, we need to add a conditional in the while loop. So that's something we need to do. So how can we do that? We can just put, for example, an integer or a Boolean. Sorry, we can just say guessed correct. And we just set that to false for now. Capital F. And then while guessed correct equals false, we can keep running this loop. Right? And to set that correct whenever we get the correct number, so we can just put temporarily just an if statement. If guess equals answer, and print that's correct. Oh, I shouldn't put the yeah, correct. And then we can set guessed correct equals to true. All right, so now we've got a basic loop going. We can run this and see, are there any issues that would, any other issues that would come up? Takeshi, you got a question?
Mhm.
Oh, no questions? No, sorry, my bad. All right. So remember, we want to reorder these if statements, right? Because if we guess it correct, we want to end the loop first. So we want to put all this stuff at the top. We'll run that check first.
Mhm.
Move this over. If guess equals answer, then we're already done, right? If this doesn't work, oh, sorry, move that here. Should go on top. Then we can put elif guess is greater than answer. Then we can print incorrect. And the elif guess is less than answer, print incorrect, guess higher. And then now we have our loop. So let's try it out. Hit run here. It's going to say guess a number between 1 and 100. Let's start at 50. It says incorrect, guess higher. So we'll guess 75. Incorrect, guess higher. We'll guess 85. Incorrect, guess higher. Am I getting an issue here? No. Well, let's guess higher. We'll guess 90. Even higher, 95. And now it tells us to guess lower, right? So let's guess 92, 93, 90. Oh, I pressed 03, my bad, 93. That's correct. All right, so that's a solution to the homework. So hopefully that makes sense for the people that didn't figure it out. Do you have any questions on this? Did a different way? I did. Oh yeah, so another solution here that Ian said is instead of putting setting a Boolean here, and then when it's correct, you set that Boolean correct. You can also just do while guess is not equal to the answer. And this is another great solution, right? This works just as well. Remember, the guess will stay that integer. It doesn't go away after the input, so it'll stay there and it'll keep looping until this is true. So yeah, that's another solution. Cool. Does anyone else have a different solution or any other questions? All right, no questions. Cool. Let's move on. Comment this out here so that number can still, that code can still work. All right, and now let's shift over to this. We have today's class PowerPoint. Today we're going to be going over some slightly more advanced functions. Okay, so starting out with the default argument. We all remember how with the function here that we define, let's look at the bottom here. If we define a function, we can set different variables that we give to the function as inputs, right? But the default argument is that you can set one of these potential inputs to a predetermined variable. So if you wouldn't, if you were to call the function and not give that input, this function would just treat that input as what you set it as. So let's look at this example. We define a function called student. The student takes in a few inputs. We got first name, last name, and standard, right? And after that, it'll print these in a special order. But here in this function, we have last name and standard as default arguments. So we set last name equals to Mark, standard equals to fifth. So we look down here, we call the function, we say student John. We only give one input. So we only give first name equals to John. The other Two variables here weren't given inputs, so it just reverts to the default argument. So as you can see, we run this function, even though we didn't give last name in standard, it'll print John Mark studies in 5th standard. So it prints out the first name. Oh, sorry, I didn't mean to skip the slide. It prints out the first name, the last name, studies in, standard, and then standard. So this can be useful for sometimes, let's say you want to have a function that could take in a few inputs, but you want this function to be flexible. So you can either use it for more functionality or less. You can use default arguments to do that. All right, so any questions about this? All right, let's move on. So next off, we have the keyword argument. So the keyword argument will specify the keyword to which the value goes. This allows you to pass arguments down in random orders. So default argument here, we have first name equals John. We have keyword argument, first name equals John. Right, so the difference is that the keyword argument is for when we're calling it. So for example, let's go back to this example here. What if we wanted to call this function student, but only give the first name and the standard, right? We don't want to put last name equals none, because then I'll take last name equals none as an input, right? So what we can do is use a keyword argument and define that when we call the function. So let's type this out in Collab real quick. All right, define student, and this function will take in first name, last name. What was the last name here? Last name Mark. All right, last name Mark, standard equals fit. And in this function, all we do is just print first name, last name, standard. Oh, is also studies in standard. So there's the function we had. We'll run this cell to define the function. Down here, if we call student John Mark studies in 5th standard. So again, this is the default arguments kicking in. We didn't have to give it the other inputs, but it'll still take those. But again, if you want to define just the first name and standard, we can do first name equals John. If we only leave that there and we run it, it's the same thing, still works. But then we can put standard equals 4th. And you can see we can get John Mark studies in 4th standard, right? So the order of the inputs we were giving it is first name and standard, right? So we skipped over the last name here, but that still works because we told the function specifically the keywords. Oh, someone messaged in the chat. Oh, okay. Cool, so any questions about this? If you guys could give me a thumbs up if you're all getting it. Again, any questions you guys have, feel free to ask. You know, you can always go back to go. All right, Ian's giving thumbs up. He's got it. Anyone else? Oh, save that for later. Morgan's got it. Jaden's got it. All right, cool. Let's move on. Go back to this presentation. All right, next up, we're going to go over arbitrary arguments. So again, this is another thing for passing in inputs to a function. But this time, it allows the function to accept any number of positional arguments. All right, so what does that mean? What if we don't know how many inputs the function is going to get? All right, so if we look down at this example here, let's not worry about the syntax yet. We have a function here called person, and this takes in args. So args is all the arguments that this function can take in. It's an arbitrary argument. So that means we can pass it in many arguments. So all this function does is it prints out what it was given as an input. So let's look at here. We call person. We give it the inputs Sean, male, 38 London, and I assume that's his phone number. So we're giving this function some information about Sean. So even though we only have one input definition here, when you print it out, you can do information about the person includes or include all of the inputs that we gave it. Cool. Does that make sense? All right, cool. Got a few people nodding heads. All right, so again, this is just to give more flexibility for you when you're defining our functions to take in inputs. All right. Next up, let's look at error handling. So error handling in Python is done with try, except, else, and we'll also look at some blocks here. So let's first go over breakdown. So what is try and except? Try and except is used for when you want to catch an error in your code. Normally, errors in your code are really not good, right? You get an error, your code stops, everything breaks. But with try and except, you can catch any expected errors that you might get, and then your code can avoid them, right? So let's not worry about the syntax yet. Let's first focus about try and except. So a real world application would be, for example, let's say you're trying to scrape a bunch of images from a folder on your computer, right? Some of those images might be corrupted. So when you try to open those images in your code, you might get an error. But if you use try and except, you can avoid that. So let's do an example with try and except. So first of all, let's look at some syntax for this. It's pretty simple. It's kind of like if-else statements. You have try. Oh, sorry. Didn't mean to skip the slide forward. So we first have try, and then under that, in the indent, we type the code we want to be tested for exceptions. So here is the code that might get bug, a code you expect that, might break. So it'll try to run that. If it runs that code, no bugs, everything's good. It'll skip over the rest of these blocks, and then the program will keep going. But if this code does break, it'll move on to except one, and it'll handle exception one. You can always do more exceptions. You have more than one exception, you do except two. And usually that's all you would use, just to try and except. But if you also want to execute something if there's no exception, only if there's no exception, then you can add an else block here that will execute. There's no exception. And if you want something to execute always, you can use the finally block. So finally, and then it'll run the code that is always executed. All right, so do you have any quick questions about that? Don't worry if it's still a little bit confusing. We'll go over an example and I'll clear everything up. All right, so all good? Let's try it. So let's just make an edit to our student function. So let's say, for example, we want to typecast standard to a string. We want to print standard as a string. We also want to print first name as a string and last name as a string. So in print functions, you wouldn't really need this, but I think a more accurate, just call it this, result equals, and then we can put all this in here. So you don't need to typecast things to strings when you're using print, but if you were to put it in a variable, you would need to do that. Oh, wait, no, I should do that. Sorry about that. 1 second, let me remove the. And instead of printing all this down here, we'll just do print result. All right, so we made a few changes to this function. Instead of just directly printing everything out and just doing all of that in the print statement, we will first set that as result. So result is just equal to all the strings we have as our input, and we'll add them up. So let's run that function. And we can just call student John. Oh, I have to add a space. Sorry about that. I forgot to add a space between the words. It'll look kind of weird. There you go. Now it's readable. So we got a few spaces in here. All right, so the same thing, but now we set it as result. And remember, when we're adding things together to create a longer string, you have to add all strings together. So if we were to add, in this case, it works, right? Because first name is a string, this is a string, last name is a string, and so on. But if we were to try to add something that's not a string, we would get an error. So for example, let's call student 1. And that here we get a type error. Type error just means you can't add ints and strings together, right? Well, what if we do have someone named 1, right? How would we change this function to make it work? Well, you can use try and accept. We'll do try, no, not tr, we'll do try. And we'll try this code here, except, and you can just do result, something went wrong. Define that function again. And as you can see, something went wrong. So we did get a bug here, but our code didn't crash. It's still finished. And that's an example of how you can use try and accept. Accept. So does that make sense, everyone? If you guys could give me thumbs up to let me know you're all good. Oh, sorry, Morgan's good. Jaden's good. All right. So what if, let's go back to our example here. Let's say we do have a student and the student's name is 1, just the number. How can we change this code to make it print all of this, but with 1? Right. One solution here is we can just typecast it. We can just do string for our first name, and that would fix everything. All right, so now we can do 1. But what if we want to do this using the try and accept? Anyone have any ideas? No? Well, you can just put something in except, right? So except runs when try doesn't work. So if try doesn't work, and let's say for some reason, normally we don't want to typecast it, we can just typecast it in our except. Define the function again. And now you can see it works. You have 1 mark, studies in 5th standard. All good? All right, cool. So now let's go on to use some of the other blocks that we learned. We also have the else block. And we have the finally block. So the finally block is something that will always run, right? So in this case, it would make sense to have it return the result. So we can get output for the function. And what's something we can do in else? Else only runs if there's no exception. Right? So if we have except we print something went wrong, then we can do something went wrong. And in the else, we can print nothing went wrong. Find the function again. So we have something went wrong that tells us it ran the except here, and it prints it out okay. And again, because we're returning the result, we can also have this as a variable. Let's just call it temp string. And then we can print temp string. So again, all the same things. That's how we can use try and accept. So do we have any questions about this? You guys, Morgan's all good? Cool. Good job. Everyone else? All right, cool. So now that we've gone over this example, let's do quick practice using the try and accept. Let me pull this up. Give me a second. Okay, so let's do a quick practice while I try to recover some files. But for now, let's say we have a new function here. We'll call this divider. This will take in two inputs, just A and B. Oh, it's giving me a lot of code. We're going to ignore that. And the goal for this function is to divide A and B, and then return the output. And then make sure this can work even if we accidentally divide by 0. So can you guys work on coding a quick function for that real quick? And just to demonstrate the issue that you'll get if you just do return A divided by B, let's say we call divider, divider, divider. I cannot spell today. 1, 0, and we divide that. It'll return a 0 division error. So you want to be able to handle this error in the code. So we've got one correct solution so far. Anyone else so far? Okay, since it's been a while, I'll just go over the solution real quick. No worries if you guys weren't able to figure it out. So we saw the issue with the current function, right? Let me zoom in a little bit more. We just return A divided by B, pretty simple. So that'll work for most things. So we're going to do 2 divided by 4, gives us 0.5. Divide that by 8, 0.25. But if you divide anything by 0, you get the 0 division error. And then in this case, it doesn't output anything, your code breaks. So the solution to this is just to use try and accept. So you'll try to return. Oh, the AI is pretty powerful. I already coded everything. Try not to use the AI since you're still learning, but we're going to try to do result equals A divided by B, or you can just directly return it. Return A divided by B. And if that doesn't work, accept. You can do print something went wrong. Please try again. And then we can just do a second return. So that works right there. Now, if you do this, if you run this code here, it'll do something went wrong. Please try again. All right. So what this code does here, this accept here is looking for any errors that the code gives. If anything goes wrong, it'll print this. All right. Remember earlier in the PowerPoint, we went over how we can have multiple accepts. All right. So in this case, remember the error is called 0 division error. You can do accept 0 division error. And what this does is this changes the accept thing to look for a specific error. So does that make sense here? If we update the code to this, nothing will change because we're still getting the same types of errors each time, in this function at least. But if you're writing a more complicated function, you need to look out for multiple errors you can specify them by doing this. All right. So any questions about this? Hopefully you guys all understand what's happening. All good? All right. So let's go back to the presentation. Let's keep going. The slides. Oh, we already did the division. So next up, let's look at a new type of data structure. So we've all gone over lists so far. So now let's look over dictionaries. So dictionaries are kind of like lists too. You can store a bunch of data in them. But the difference is that it stores the value in this kind of structure here, where it has a key and then value pairs. So what does that mean? When you store values or information in a dictionary, each piece of information that you put into the dictionary is corresponding with a key. And this key is usually just a string. It's just a name for your data, right? So you can use that key to find the data here. And again, values in the dictionary can be of any data type. You can have duplicates. Everything is fine here. And keys are immutable data types and cannot be duplicated. So what does that mean? For example, you can't have two keys that are the same thing here. Otherwise, you're going to have an issue. Right? And the syntax for the dictionary is pretty basic. Instead of using square brackets like a list, we'll use curly brackets. And then for each element in the dictionary, that's the word. For each element, we're going to have the key separated with colon and then the value, and then each element is separated by a comma. All right, so dictionaries are really important. So let's go over a quick example of dictionary. So most basic example, let's just call this people info. We'll define it as a dictionary. To make it easier to read, I'll just open it up like that. All right, we can say, we'll call this Max info. So say we want to store the information about someone named Max. So we can have first name equals Max, last name equals, we can have hobbies. What was it? Genshin. And you want to put these in quotes here. Pet. I'll just call it dog. All right. So that's the basic way to set up a dictionary. You've defined this dictionary here as called Max Info. Inside here, we can store some information about him. The key for the first piece, the first element is first name. Oh, Michael says, can I use the restroom? Yeah, feel free, go ahead. Don't worry. If you come back, I'll do a quick recap for you. No worries. All right, so again, for the first element here, this is the first element. We have the key first name and then the value Max. We have the key last name and then the value Len, and then the same thing for the other ones. So we can run the cell to define this dictionary. And how do we actually use the dictionary? Well, kind of like a list, right? When you have a list, what do you do for the list? You'll put square brackets at the end and then use that to index. All right, so here we do the same thing, but instead of indexing for using the index, we'll use the key. So say we want to get his first name, run that, returns Max. So the dictionary took in this input here, it looked for the key inside the dictionary, and then returned the value that was corresponding with that key. All right, so does that make sense? Well, no water. Dang, I'll get some later. Does that make sense, everyone? All right, got some thumbs up. All good. So right now we're just using this with strings, but again, you can also do this with other types. Like for example, you can do age and then 25. So this is an integer here, right? And let's say Max has multiple hobbies. We can also put a list here. Genshin, tennis, robotics, right? So now we have strings, we have lists inside the dictionary, integers. So all these data types will work. And let's do some more exercises on accessing the information from this. So for example, we want to get something from his hobbies, right? So looking at his hobbies here, his hobbies has a list here. What if I want to get this to return tennis? What should I type in the back here? What should I type in the back here if I want to get it to return the string tennis from this dictionary? Morgan's his hobby? Yes. So first of all, you want to start with hobby, right? Because let's go layers at a time. So first layer, you want to go inside the dictionary. You want to find the list here, right? And so the key corresponding with this list is hobbies. So we put square brackets here, hobbies. All right, so we run this. Oh, I didn't define that. There you go. So now if we run this, it gives us this list, right? So now how can we find tennis? Yeah, Jaden says hobbies, and then you put square bracket 1. Exactly. Great job. All right, so why is that? How does that work? After you call max info hobbies, this here becomes a list, right? Because it's going inside the dictionary, it's finding that list. So now this is a list. Then you can treat it as a list. So when we're looking for things in a list, we use our index. We do that with square brackets here. So you can just put square brackets here in the index. All right, does that make sense? All right. So dictionaries are really important. When I first started coding, I thought that the keys were kind of redundant, but as you start dealing with more and more data, the keys will allow you to stay organized and manage a lot of data to process. All right, let's go back to the presentation. All right, next up, the items operation. So I really didn't go over this. First of all, we got pretty good overview what a dictionary is. Now let's go over some more of the functions, I guess. So the items method returns a view object containing the key value pairs of the dictionary as tuples in a list. All right, so let's break down. What does that mean? It returns a view object. All right, so this object is just another thing in the code that you can use to access information from. This object contains the key value pairs, right? So as you can see down here, we do print X, it returns all of these pairs. Brand paired with Ford, model paired with Mustang, year paired with 1964, right? Just like in our dictionary. And then it returns these pairs as tuples. So each one of these pairs is a tuple. And all these tuples are grouped together in a list, right? So now let's go over that real quick. So let me see if I can remember all this. I'm going to type it over here. We'll have a new dictionary called car. Oh, would you look at that? AI gets better each day. All right, so I don't even need to type that anymore. It looks like it already knows what I want to do. So now let's do car dot items. Just take a look. It prints dict items. That's the object right there. Then inside we have all of these things here. And we can access every one of these pieces of information, again, just like a list. Dict objects not subscriptable. All right, 1 sec. That's not part of the lesson plan. Well, I'll get back to that in a second, but I guess, uh, my bad. Anyways, so the items here returns all the pairs. So when you're looking at a new dictionary in the code, you can use that to get an overview of it. And that's it for now. So we've gone over pretty fast. We were 8 minutes early for the first hour. But now I've got a pretty good hold on some more advanced functions. We got try except down, and we all know how to use dictionaries. So do you have any questions about that? Other than the items, I will figure that out. Any questions about stuff that we went over so far? Nope, no? All right, since we finished early, you guys can go take your break. We'll just do a quick 10-minute break in the middle because I know 2 hours is a long time to stay sitting. So since it's 7:53, let's try to be back at 8:03 for the 10-minute break. All right, 2 people back. Anyone else? Hopefully no one forgot to come back to class. Oh, Michael's here. I see him. Cool. And Ian's back. Cool. All right, let's get started. Continue some stuff. So first of all, before we go over some new concepts, go back to this issue here. The items, you don't usually subscript this. So what you would actually do with the items, so again, the items is just returning all the pairs in your dictionary. You would just do for item in var.items. And then you can use this to loop through your dictionary. So for each item here, you can access the information using item. But that's how you would use this. Same thing with car.keys and so on. You wouldn't just access them with indexing. But now that that's addressed, let's go over some quick practice to use what we have done earlier. So let's start off with this exercise. Create markdown here. Oh, wait, there you go. So you have an exercise here to create a function that accepts the arguments. It'll take these arguments in, first name, last name, and age, and the function will output their first name, last name, age, and ability to work. So age is greater than 18, true. So let me get you started with this little challenge. Def work ID, first name, last name, age. So it should be hopefully a quick problem. You got an answer from Ian. Oh, good job. You wrote a very big function. Yeah, good job. Nice. Yeah, looks great, Ian. Anyone else? Haven't gotten a response from others, so let's go ahead and I'll explain this so we can get to keep moving on. So all we want to do is to simply output their first name, last name, age, and ability to work. So the first name, last name, and age we've already been given. From the function inputs, all you need to do is see ability to work. So that's if age is greater than 18. So we can just do able to work. This will be our Boolean. Oh, dang, this AI is really annoying. And then if age is greater than or equal to 18, and we use greater than or equal to because 18 also works, that's our if statement, then we'll set able to work equals true. And then after that, we can just print everything we need, which is first name, last name, age, and then ability to work. Oh. Find that function here. Now we can run test code on that. Oh, not generate. Sorry, do not want to use that. Oh, sorry, I typed something wrong. And there you go. So we got name, age, first name, last name, age, and then unable to work. But Ian, great job. You added a little bit extra. Always good. So just a quick little warm up to get back into things. And we'll move on to a few more slides. So now we'll talk about nested loops. So nested loops is a very powerful concept in programming to allow you to do a lot of functions a lot more easily. So what is a nested loop? It's just a loop inside another loop, right? Pretty simple. So the outer loop will run its block of code, and then each time you run the outer loop, the inner loop will also run. So you can often use this to access multi-dimensional data structures, such as lists of lists, right? So you have a list inside a list. You want to iterate through everything in that data set. You can use a nested loop. So now we'll go over some syntax of loops. So first of all, the concept here, the outer loop will define the primary loop. This contains the inner loop. The inner loop, you put it inside the outer loop, and it will run the full loop every single time the outer loop runs. And then the index block is just for syntax. So let's look at this example here. Say we have a matrix here. Matrix is defined as a list. And for each list inside a matrix, we have, and for each element inside a matrix, we also have another list. So we have a list of 3 numbers, another 3 numbers, and another 3 numbers. Right, so our matrix list is 3 elements long, and then each list in that is also 3 elements long. And say we want to print every single element, we can first do for row in matrix, right? So now row is the row in the matrix, and inside the outer loop, we run another loop. This is for element in row, and every single time this inner row runs, we're going to print the element. And this end here just adds another space at the end. And then we can print here to do a new line. So let's look at that in Colab. Let's find our matrix here. Oh, not the curly brackets. Oh, what is going on? All right, cool. So now we have our matrix. We want to iterate through every single element in the matrix. And starting off for row in matrix here, right? So this loop here goes through every single row. In this case, there's only 3. But every single time we go to that row, right? We start off here, we go to the first row. We want to run this loop again for every element in that row. For element in row, print element, and then we can add a little space at the end. And here you can see we've iterated through the whole list. We can print 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, does that make sense, everyone? And if you have any questions about this, feel free to ask me real quick. Is everyone okay? All right, Ian's got it. Anyone else? All right, Morgan's also got it. Hopefully everyone else has too. And again, if you have questions about this later on, feel free to ask me. So we've got that. Let's move on to our first exercise with this new nested loops. We want to write a function. This function will be called numMountain. So make a mountain out of numbers. And then we want it to create a number mountain, right? So let's look at these two examples here that we've given. I should full screen this. We call number mountain, and we give an input of 5. It'll make a number mountain that is 5 rows tall, and then it'll just print down like that. So the challenge is to write this using nested loops. All right, so to get started, again, I'll start you guys off real quick. Let me make a new cell. We'll define the function, num mountain, and then we'll have height as the input. And then we want to start with loop, right? For I in range height. So that's the outer loop. From here, oh dang, wait, this AI is really annoying. Pretend you guys didn't see the AI there. So that's your little hint to get started. And let's try to work on this for a few minutes. If you get stuck, feel free to ask me. Just copy this PowerPoint. Can we look at the prompt again? Yeah, of course, of course. Sorry, I should have left that on here. In here. So we want to create a function called num mountain, right? And this num mountain will be given an input that's an integer, and this will define the height. So for, let's say here, this example, we give it the input of 5, it'll print out number mountain that's 5 rows tall. And each time it'll just print down 1, 1, 2, and then it'll just add numbers to the end. So the goal is just to print out a number mountain, and you can do this using for loops. All right, so does that make sense? Hopefully the prompt is clear. Michael needs another hint. All right, no worries. And Morgan, if you want to send me your code in the chat, yeah, you can just not really getting it. No worries, Michael. So let's go over this again. So going back down here, do you see where my cursor is? We have this little mini number mountain, right? So when drawing this number mountain, I'll just redraw it. Let's think of in loops. So obviously we want to have 2 for loops, right? So basically 4, and inside that we have another for loop. So we have 2 loops. Each time that first loop runs, the second loop will run. Everything in it. So basically, how should go back to, we have a diagram in here. This diagram might actually be a little much. Let's go back in here. Let's just say for I in range, let's just say 10. And the inside for j in range, 10. Print ran inner loop, print ran outer loop. Well, maybe we shouldn't do 10, that might be too much. Okay, so let's look at this code here. We have 2 for loops, right? These are nested loops because we have the inner loop inside this outer loop. So this outer loop will run 3 times because we're doing for I in range 3. And the inner loop will also run 3 times for I in range 3. All right, so let's look at how this code will run. We start off with number 1, it runs 4, so it starts the loop. Inside this loop, we see another for loop, right? So the code will first loop through this section 3 times. It'll go 1, 2, 3. So you can see here it prints ran inner loop 3 times. And then now that loop has finished. Once the inner loop has finished, it sees that it's still in a loop. It'll finish executing everything in that loop, and then it'll go back to the top and do it again. All right, so we do all 3 for the inner loops, ran inner loop 3 times. We finish that inner loop. We finish our outer loop, and then we go back to the top and do it again. 3 times for the inner loop, 1 time for the outer loop, or just the print statement from the outer loop, and then again. So you can see we have 3 of these kind of blocks, right? We have 1 block here, another block here, another block here. And each block is each time this inner loop ran, and it ran 3 times because the outer loop runs 3 times. Morgan says, I'm stuck. I thought the code was finished, but I don't understand. No worries, no worries. We'll go over that real quick. So Michael, does this explanation make a little bit more sense for how the nested loops work? And then I'll go over the question. So Michael, did that help or? I ran the same code and it's giving errors. Um, how is it giving errors? Makes more sense. All right, that's good that you're understanding. Um, Michael, it shouldn't give errors. It might be just a small problem, so don't worry about it too much. Let's go over the actual solution for this, right? So the actual solution is very similar to this, right? We want to start off, first of all, with the loop. For I in range height. So what this first loop does is it'll run for as many times as we need it to for the height, right? So if you give it the input of 10, it'll run 10 times and that'll create 10 rows, right? But for each row, we also need to fill it out with adding all those different columns in. So now we can do another loop. For j, we're going to use a separate variable here than I because we don't want these to change each other's variables while it's running. For I in range, or for j in range, I. Right? So what does this do? Each time we run this loop, I increases, right? The first time it runs through this loop, I is 0, second time 1, then 2, then 3, and so on, right? Each time we run that loop, we run that outer loop, we run that inner loop to run another time. So we pass it in for a range of I. So just do print inner loop, and we can already see what's happening down here. And then I'll just do print outer loop. So this is not the finished, oh, this is not the finished function, but let's just take a look at what's happening real quick. We'll call num mountain, and let's say we want to make 3. So you run that outer loop, the inner loop once, the outer loop, and then the inner loop twice. So you can see the inner loop is increasing, right? All right, so now we have the basic structure for what we need. Now we just actually have to make the stuff. So let's just define a quick string here called row, right? This is actually what we're going to be printing out for each row. Right now it's empty because we need to fill it out with this second loop. And then here we can just do row plus equals the string of j. So what is this doing? It's adding the number j to the row, right? Because remember, for our number mountain, we want to print numbers each time. And the reason why we put string here is because we want this to be a string. We're adding it to the row, which is already a string. And just to make everything look nice, you can just do row plus equals an empty space, so it'll look better. And then now we've made that row. So we're in the outer loop. The inner loop just finished running. Our row is all filled out. All we need to do now is print the row. So enter the code here. We have a little number mountain. Not a very impressive number mountain. So why is that? We have 3 here, and it's only printing out 1 and 2. Why is that? Well, it's because we're doing for I in range height, right? We didn't pass it in a range, we just passed it in a number. So it'll start at 0 and then run all the way up to that number. And in this case, it was 3. So we want to fix that. We just do 1 to height plus 1. And then now we have 3. And now we're pretty close to the example, but in the example that we gave, each time it was printing 1, 1, 2, and then 1, 2, 3. Very simple fix. Every single time we add a number here, we can just do plus 1. Define that, and we have a number mountain. So we can make a number mountain of 3, number mountain 15, and it'll make that. Okay, so any questions about this? If you have any confusion about this, feel free to let me know. All right, Morgan's got it. Anyone else? All right, cool. Ian's also got it. We have one question now. I'm not sure about the outer loop for condition. Not sure about the outer loop for condition. Oh, the for condition in here. So we're doing for I. So I is the variable that'll increase each time, and then the range is going from 1 to height plus 1. So in this example here, we passed in 3 as the height, right? So it's becoming for I in range 1, 2, 3 plus 1. So it's going from 1 to 4. Right? And what that does, if you just print I, you comment out the number mountain, it'll go 1, 2, 3. Yes, range is exclusive at the end and it's inclusive at the beginning. And remember, when you don't pass in an actual range, you just pass in a number, it'll start at 0. All right, cool. Glad that makes sense. Anyone else? Any other questions? No? All right, so let's move on to another fun problem. So we've got a little bit of practice from the number mountain. Let's look at creating a 10 by 10 multiplication table. So this time, a little bit more interesting. We're also printing a bunch of numbers on the screen, but this time we want to print it in the shape of a multiplication table. So you can see here, 2 times 2 is 4, 2 times 3 is 6, and you can so on. Everything here will match. So again, get started down here. I'll just make a new cell if I can find it. There it is. Code multiplication table. Oh, this AI is really annoying. It's giving me away all the answers. And we'll just give it size. So the goal is to print out a multiplication table of size. We'll just do size by size. All right, so for example, if I gave it input, for example, if size equals 3, we want a 3 by 3 multiplication table. So this is kind of a hard problem. So before you guys all start trying to code, let's think about this for a second. Try to think about the logic that we could use to solve this. Oh, Ian says, can I see the code for the number mountain? Yes, of course. Let me pull it up. It's right here. I'll just copy this down so we can still see at the bottom. Oh, that's not what I copied. Copy this. There you go. So there's the number mountain code. All right, so now that we've all thought about it for a minute, let's think about how we can do this. Right? It seems kind of scary compared to the number mountain, but let's think about what we actually have to do to make this. So again, we'll just draw a multiplication table. So obviously we're gonna have to use nested loops. So we want a loop inside a loop. So let's think about what we do for the outer loop. Each outer loop, again, is gonna be the row. Each inner loop is gonna be each column, right? So let's say we give it size 3. We want to print a 3 by 3 table. So what is that gonna look like? I'm gonna rack my brain here. 3 by 3 table is gonna be 1, 2, 3, 1, 2, 3, and okay. 1, 2, 3, 1, 2. Oh, dang, this AI is really good. What the heck? Okay, so there's the table that we want to print out, right? So let's break it down. We're looping through. We're the first loop through. We're at this row. So now we want to have a loop to print it out. We're going to print the first time through that inner loop. We're going to print 1. Second time through, we're going to print 2. Third time through, we print 3. Okay, then again, we're at the second loop of the outside one, and then the inner loop starts. We print 2, 4, 6, and then we do another outside loop. We print 3, 6, 9. So So let's try to find the pattern here, right? I'll just copy that nested loop I had. And each time we're in here, let's print inner loop. Okay, so now we can see what's kind of happening when we run these nested loops. So again, we're trying to do a 3 by 3, so we pass in 3. And let's see, the first time through, oh, it's another bad example. Let's do 1 to 4, just to make sure we don't have zeros here. First time through, we have 1 and 1, so it's at this point. The second time through, 2 and 1, right here. The third time through, we're at this point, 3, 1. And then we go back to the top. So this is the inner loop done. We go back to the top. We start over again. We're back at the inner loop. Now we're at 1 and 2, this position. 4 is when we're at 2, 2, because we're at the second iteration of the outer loop and the second iteration of the inner loop. So are you guys noticing a pattern? Pattern that we can use to create this multiplication table? Anyone have an idea? No? Well, let's look at this. Every single number here is just the product of our inner and outer loop, right? So you can see if you look down here, let's say the last one, we have 3 and 3. If you look at that position inside our multiplication table, it's 9. So now our logic is a little bit more simple, right? We want to have outer loop runs for size. Inner loop also runs for size, because this time we're trying to print a square, not a triangle. And then for each iteration of the inner loop, print the inner loop index multiplied by the outer loop index. And that's it. That should give us our multiplication table. So with this sort of pseudocode, can you guys try to write the actual function? And again, I'll scroll up so the number mountain is still visible. I should just zoom out a little bit, actually. There you go. So now that we've gone over the sort of logic for this function, let's try to write it out. Okay, so Michael's almost there. It's just a small issue. Anyone else? Don't worry, Michael, we'll go over that. Also almost. So Ian, do you want some more time to finish it up, or do you want me to go over the explanation? Stuck? All right, no worries. So let's go over this. So we have our 2 loops, right? So let's first of all, and the AI. All right, so first of all, let's start by defining our outer loop. So for I in range, it already knows what I want to type, I guess. We're gonna have 1 all the way to size plus 1. And the reason we do this is, again, if we just have it do range for size, it's going to start at 0. And for the multiplication table, it's going to give us a lot of empty numbers. Same thing for the inside one. For j in range, 1 to size plus 1. And again, we're using I and j separate variables so that they don't talk to each other. If we have both set as I will keep changing randomly. You'll have all sorts of issues. And remember here what we had is for each iteration of the inner loop, we want to print the inner loop index times the outer loop index. So that's just I times j. If we want to write it in a similar fashion to num mountain, we can just have row equals a empty string here. And then for each loop inside, we can fill it up. So row plus equals, we're going to typecast this because again, we're adding it to a string. So we do string I times j. And then just to make things look nice, we can just add a space. And then once that inner loop is all done running, we do a print row at the end. So it'll start by clearing the row, it'll fill up the row, print it, and then move on to the next one. So now we can run this cell to define our multiplication table and call multiplication table and start with 3. So as you can see, the table that outputs here matches with what we have in here. Oh, Ian says forgot to move the print row to the outer loop. Cool, no worries. All right, so does that make sense, everyone? If you have any questions left about this? So a few people forgot to put the print row outside of the inner loop. No worries. Okay, so now let's work on another practice problem. Oh, I should have written this. I'll make a student's info dictionary. So this is some more exercise with looping through and filling up dictionaries. So I'll define a dictionary full of some student information. And the goal is to find people that have matching information. So we'll have some inputs here. We'll try to find the matching. Why do I keep putting curly brackets? There you go. Fighting the AI as I type here. Making up some names here. And I'll just duplicate that for a few. All right, see kind of creative names I can come up with. No, something got deleted. No worries. I'll change some of this. So while I'm typing all this out, do you guys have any questions from what we had earlier? I'm running out of ideas. Go with the classic. Max. He's very tall. It's a good last name. First one that came to mind. Have this guy also be 17. And I'm too lazy. We're not typing the last two. All right, so here's a challenge. We've had this dictionary here. I'm going to give it to you guys in the chat. So you can copy that into your code. And the goal is to sort through the student's info to find people with, so find everyone with age 14. Find everyone with height 200. And then find everyone with height say very specifically, we're gonna look for height 197, age 17. So this student's info is just a list. As you can see, we have the square brackets over here. Oh, sorry. There's an issue with the one I sent, and there's an extra comma at the end. Just make sure to delete that. But so this is a list of dictionaries. So each dictionary inside this list has the information for all the students, and the goal is to loop through this list. And then for every dictionary you find in that big list, I'm going to loop through it again. So some pseudocode here, loop through every dictionary in the students info list. Oh, we might not have time. It's 8:58. This is going to be the last problem for today. Loop through the dictionary in there. This is just a good exercise to work on that. But since it's getting kind of late, it's 8:59. I took a few minutes to write the students' info, so I might just put this for homework for next time. But let's wrap up the end of class. Sorry, that last bit was a little bit hectic. But with everything that we've gone over in these first 3 days, we've pretty much got all you need to um, go pretty far with Python. The good part about Python as a programming language is that you don't have to learn too much of the basics, because most of what you're going to have to learn is specific to what libraries you use. So with each new library that you use in the future, so we've already gone over like random, for example, but for other libraries that you use, you're going to have to learn everything in there. So with what we've learned in these 3 classes, it should be enough to get up and running with most libraries. But next class, we will be going over time and turtle, just as little introduction for using libraries and also for some fun. But that's it for today. That last problem that I took too long to type will be homework. And then there'll be some other stuff. Is there gonna be another teacher for tomorrow? Yes, I think I won't be able to do it. It'll be another person, but I will be here after for the office hours when you guys are working on the final projects. So if there are no other questions, that's it for today. Sorry that last bit was a little bit hectic. I should have heard that the students' info in advance, but the multiplication table is homework. Oh no, the multiplication table is not homework. So to be clear, this will be homework. We'll send this out along with some other questions. So it won't be a lot. It'll be like this and maybe another 1 or 2 questions. But yeah, you guys don't have to worry about copying stuff from the Zoom. I'll send it out. So that's it for today. I won't keep you guys any longer. 2 hours is a long time. So yeah, good job, guys. Thank you.